Hello friends, I am Anand Sahakar. Today I am going to create a video over how to download the satellite image data. So uh, I want to tell you why I am curious about making these videos is because in last semester I have completed the remote sensing course as a part of my coursework. Before this I just knew about the satellite images. I heard about some softwares and some graded data and all that, but I have never heard of never learned before about how to do the image processing thing and how can we make use of these satellite images and make composites. But now I have a clear idea about how we can make the composite and we can explore and extract the features that is of our use. So uh, this is the first video I'm starting with. So let us look for some portals. So simply I have searched for the satellite image download portal, and here we got this geography blog. I'm opening this. This is the first blog. uh, so it explores various portals that provide a satellite imagery like USGS Earth Explorer. This is very popular one. I have used this during my class to download the Landsat 8 or 9 images, right? So the portal looks like this, and other portals are Sentinel Copernicus browser. We will also look at this. The difference is Sentinel provide that 10-meter resolution data. See, Sentinel-2 has 10-meter resolution in RGB and near infrared, and it provides 12 spectral bands, right? Whereas this Landsat provide 11 bands, um, out of which 7 has this 30-meter resolution and the rest has variable 150, 100-meter resolution. Basically, there is one NASA Earth data search and other. We will not explore all. In this video, I will explain Earth Explorer and Sentinel Copernicus browser. Right. Following this, the next video will explain the satellite image downloading process from this ISRO portal, like Bhuvan and Bhunidhi portal. So we will look those portal in next video. So let us move quickly to the USGS portal. This is the USGS viewport, right? Earth Explorer viewport. And as you can see, this is the US government website. This is provided by data is provided by US government. So uh, we have multiple options. Select the location such as circle. So in case of circle, if I tap on some point, it grabs the latitude and longitude of that point, and we have to give the radius. Basically, if I give 20,000, say 20 kilometers, we can select kilometer, respect 20. We apply, it select area and radial region, right? Now I'm clearing it. They also provide predefined area. Predefined area have state, which consists of US states. However, if our region is not in an US state, then we can create the polygon, right? By simply tapping like this, right? So let us select a study area, say study area. Now let us choose the Rameswaram region, right? So to select this, let us just make quadrilateral, yes, or you can mark more number of points, as many as you want, but they allow at most 30. We have option to select the cloud cover. In case of high cloud cover, we are not able to analyze the image very perfectly. So it is better to choose the images with least cloud cover. So I am restricting the cloud cover to be in the range of 0 to 10%, and we have option to select the date interval from when to when I want images. So let us uh, choose November to December. Right. So this is the initial date. The final date is December 2024. Let us select the date of today. Today is 16 December. Right. Okay. In all the files, and then you have option that how many result you want on a page. So you can customize it. Anyway, let us move to the data set. Okay. Before moving to dataset, let me tell you that to download the images, you will need to create an account. So just create an account by uh, clicking on the login button. Here I have logged in. That's why it is showing logout. But if you are not logged in, then it will show login button. So just click and go to create account, enter the details, and then log in with those details and proceed like I am doing it. Right. So just simply enter those information that I have told in the previous steps. Now go to data set. Here we have different kind of imageries, right? So we have ISRO resource set also. I think they say the data. Here we have list three data set, right? But here we are not looking for this data. We are looking for this Landsat data set, right? And here we have Earth observation satellite data also. I have not excluded. We have digital maps. Anyway, we will move toward the Landsat data. So here we have Landsat collection 2 level 3 science product, uh, level 2 collection 2 level 2. These are also science products with some corrections. So let us select this, and we got a warning message. Just click OK and proceed. So we have Landsat collection 2 level 1. Level 1 data is raw unprocessed data. Basically, there is no processing done in this kind of data. Level 2 comes with some level of processing. So we have selected the collection to level 2. Right? Okay, no image is found. Let us again go with the data. We have no image found. Let's make the quadrilateral again. Right. Result. Why we are not getting the result? There might be some error. 11 December 2024. That is 1 December. Right. 1 November to 1 December. Now look for the results. Again, it is not showing the results. Okay. In that case, I will log out and refresh the website. Again, I will log in. This way, we will log in. Now we will select the study region. Right. We have selected the region. Let us skip the date interval. It will show the latest result, all the possible results it have. Okay. We have restricted the cloud cover to 10%. Then go to dataset. Then we go to the Landsat. We have here collection 2 level 2 8 9. Then go to results. Click OK. Then click results. I think this time this is the image. Now just click on this footprint button. Footprint will show where the image is actually on the map. So this one is the footprint row 143 and path 143 and row 53. So we need to just stick to the row neighboring row and path as well. So we need to look for 142. 142 is this neighboring row, and this image does not cover our study area because this is Ashram and it is not covered. So we need to look for 142 and some other. This is the same 142 and 53. This is again the same. Okay, let's click next and it will show more images, right? Oh, seems there is some error. Let's go back. It will filter out. Anyway, let us proceed with this image, right? So this this footprint button is used to locate the tile on this global map. So that we can see where this tile belongs to. Otherwise, we have another option to overlay the actual image. So when we click it, it takes some internet data and time. It actually overlays the image over the terrain map. And then we can see the metadata of that image, right? When it is captured, how it is happened. Like this is another view. Another view meaning it is captured from the top. Basically, the feature is data is extracted from top, right? And there are some details. Okay, so we have this one. Here we have option to bulk download, and we can exclude some scenes from our region of interest. We also have that option. We can use this. Otherwise, to download, just click on this button. It shows the option of surface reflectance as well as surface temperature. We will see what these parameters are in upcoming video, right? So we can add to bulk from using this button, or alternatively we can download all the files. In general terms, I use this one, this option. From here it shows all the files that is contained inside this tile. So this tile contains various band images like band 1, 2, 3, 4, 7. There is also band is there. There are some more. So just click on this button. It will start downloading in few minutes. So our download has started. This file is 762 MB. It will download in some minutes, right? So this is the method how we can download the image from this USGS Art Explorer. Now let us move toward another portal, which is our Copernicus browser, Copernicus Image Explorer. So basically we get a viewport like this. Here we have the global image. So let us extract some is from our region of interest. Like I'm going to explore the same region for simplicity. Now here we cannot just simply select by tapping, right? So we have option here, like we can select the cloud cover. Cloud cover I'm also restricting up to 10%, right? And we have options to select within the interval. So what happened? Option, yes, we have option to select between a time interval, right? So I'm selecting November 2024, 1 November to 15 December, because 2 days 16 December, right? Cloud cover is selected. Now here we have option to choose which one we want, like false color composite. It gives 843 combination. Two color composite is 432, which is RGB. Red band is 4, third band is green, and second one is blue. So true color is basically when we see an image in RGB format. RGB encoding, like RGB is the color, primary color, and combining this color we can make combination of any color that we see in our surrounding. So this is the true color, right? And if we allot some other random color or some other band, like short wave infrared or infrared band to red, green, we allot some other color. So in that case we are allotting false color, so it will create the false color composite. And this is how they represent, like in this particular portal, they are using the combination of 8 4 and 3, and every combination has its own significance. And like for vegetation we use 652, right? So there are multiple false color composite are possible. However, this is providing only one. I'm going with this true color. I have chosen the cloud cover and restricted it to 10%. Right now, let us go with this button, find product within this time range. Okay, but wait, we made some mistake. Like we need to select the study region. Okay, we have already selected. To select the study region, we can simply use this button. This is the information. This button is polygon button. Oh, our image is downloaded. Minimize that. So we can simply select this box and drag this to the study region. It will show the study areas, study region area basically, right? Here we have this. That's a small study area. Okay. Now that we have selected the study area, we can simply select on find product. So whatever images are captured during this time interval, they will be shown up here in the portal, like this one, this one, and this one. I think we have chosen a very short time interval, so we are not getting appropriate results. Let us increase it to June, right? First June, then let us see how many images we do have. Okay, when we have chosen a long time interval, then we got so many results. Basically, this image is covering our study region. Right. Just click this button to locate. This is again the same tile but with different timestamp. Let us go with this one because this is 23/7 and This one is 21.9. Okay, the above one is latest. So we will go with this one, right? You can simply add to workspace, or we can see information metadata about this file. So the file name is like this. Okay, we need to log in to download the files from this portal, right? Let us log in. I've already created the account. You need to create one. I have logged in and this entered my settings and cloud cover up to 10%. It can be allowed basically. Now select true color composite and within the interval. What interval it is let's say August, right? Then find product within the time range. And these two images I'm putting in those tiles. This one is the latest October image and this one is September. So let us go with this image. Now we can download the product simply by tapping this. I think this download as vanilla as object and blob, and let this image be downloaded. Our previous image from this handset has downloaded, and let us explore this. So our image looks uh, something like this. It is downloaded in zip file and we can simply unzip it. With unzipping, we would also be interested in knowing that what kind of file name is this and what does this mean. So for this, we just look for Landsat nomenclature. Okay, Landsat nomenclature is this. Right, we have reached the website of nomenclature. So naming convention is like this: LXSS, where L is the Landsat, X stand for the sensor that is used. So in our case, it is C. See, LC09. So C meaning OLE and TIRS. So operational land imagery and TIRS combined is used. SS. In our case, the image is LC09, which means our image is taken from Landsat 9. And then processing level LLL. So let us see, this one is L2SP, which means level 2 science product. Level 2 is processed image. Level 3 is also processed image, comes up with additional processing, whereas level 1 is technical product, which is raw and unprocessed. So this is the processing level. Then we have path. Path is the orbit where satellite pass through, right? And then row is the grid in which the region is divided into, like this one is first row, this one is second, this one is third, right? And this one represents the path. So if this is path 1, then path, if this one is path 1, let us use notepad paint to understand this. So if this is the path of satellite, then if this if this is one strip, right? So if we call this P1, then if this is row 1, then this will be our P1 R1, right? Similarly, if this row increases, then this is row number 2, so this will be on same path, but the row will be different. Similarly, there might be some other uh, path, and in this path we can have multiple rows. So the path is the region where satellite travel through. Like this is the satellite, this is capturing this much region. So this becomes a row, and when it moves, it moves to this region. This captures some other region. Then this becomes another grid, which one is row, right? So this way row and path concept works. Now we have y1dd, this is acquisition, and second y1dd timestamp is processing date basically. So in our case, this is 7th May 2024. This is the acquisition, means the date when image is captured, and then second timestamp is at 8 and 1 day after the image is captured, it is processed, right? Then we have PS, so now it is F is P1, right? And CC is collection number. CC is this 02 and P1, so collection is P and tier 1, right? This is RT image is real time and real time image is failed. This way we haven't should the convention, naming convention of Landsat. Let us see whether this image is downloaded or not. This image is also downloaded. So this is our Landsat image, and this one we will see in another video. This is the image from this Sentinel-2 data. We can also unzip it. Let us unpack the image. Meanwhile, let us explore the Landsat image. The Landsat image looks like this. Here we have one MTL file. This is a metadata file in text format. We have basically two MTL files. This is JSON. So JSON is dictionary format, JavaScript object notation, and this is the information of images what we have inside. So we have 1 to 7 band, 10 band, and there is, yes, we have 1 to 10 band. This file contains all the information about the image, like this is taken from top view, it is Nadi, which sensor is there, sensor ID is this, path, whatever corrections are made. Everything is written. Apart from this, we have one more file. I think ANG file. It consists of all the geotagging information. Now you can see all the images in this folder is in TIFF format. So this TIFF format is tabbed image format. Tabbed image format is the format of image which have geo information tagged in each pixel of the image. Like it has coordinates, latitude, longitude, and some other data. If this is red band, suppose, then it will have two, each pixel there will be one latitude and longitude allotted, and in addition there will be one digital number which will be corresponding to that band. If this is red band, then this digital number corresponds to uh, red band, red basically. This is the geotag data. This is why these image formats are quick. And if we see traditional simple formats like JPEG and PNGs, then these formats are not liable of taking the geotagging data. So they lose the details. Like this is JPEG image this time. Then if we see this image, there is no geotagging information. Only the features are visible. No data can be seen. Right, so giving these black details, but these deep images are very useful. Right, so using these images we can create the combination composite basically. If we create 432, it will be RGB. Similarly, in that sentinel image we can also create the combination. We can create a false color composite. We can calculate the reflectance. We can calculate the radiance. Reflectance is given. We can calculate the radiance and land surface temperature as well within this last 10 lines. So using this band 10, we can calculate the temperature, surface temperature, which we will see in upcoming videos. So we will explore the Lancet 9 image. Similarly, we have unpacked this Sentinel-2 image. The Sentinel-2 image I am not very much familiar with, but this is the image. We have downloaded the image. It is how image looks like. So here we have the JPEG file which shows the feature. The feature looks like this. Then we have data strip like this. We have granules, but the granules consisted inside this is in different resolutions, 10, 20, and 60, and here we have been using .jp2 format. So I'm not very much familiar with this jp2 format. We will explore in upcoming videos, right? So with this, I end this video. In next video, we will explore the Bhumidi and one portal, and we will try to download some data from the Indian Space Agency website, right? Thank you.